connected to his homemade substation ground. And at the other end, it wasn't even a complementary coil. It was just a regular ham radio setup. These frequencies that require monstrous antennas. And of course, they don't believe that he's transmitting in the ground. I have the same situation in Bolinas. I would transmit down the San Andreas Fault from Bolinas down into the Los Angeles area. And these ham radio guys would go, "What kind of antenna you got?" And I go, "None." And they refused to believe it because the signal was so damn strong. And there's no antenna. It was a coil sitting on a telephone pole connected to a ground system. And I think there's a couple other hams that are starting to get into this too. So before long, I think it'll find its way into the ham radio fraternity, so to speak. There'll be a percentage of, but don't expect any of the ham radio magazines or anybody to promote any of it. They can't to pretend that it doesn't even exist. We've already experienced, the RCA guys and I myself have experienced this long ago when we first got into this stuff.
So the output of the radio system, instead of going to an antenna, is going directly to an extra coil, which is wound and tuned to that particular different specific frequency?
Yeah. So the two terminals from the transmitter, the active lead goes to the extra coil, and the neutral lead goes to the ground system. And so basically the extra coil takes the place of the tower that you would normally see, outside the broadcasting station. The tower has been wound up into, so now rather than occupying space, it occupies counter space. And instead of consuming energy in the process, it transfers energy in the process. In other words, it sends its energy to what's receiving. It just doesn't scatter it everywhere, into electromagnetic waves, but the energy has a destination. So that makes it a lot more efficient.
So when a ham radio operator 2009 is picking it up, do they have to tie something down to the ground to get it, or are they still picking it up just using the antenna?
Yeah, they usually have what they call a ground radial system. This is on one of the lower frequency medium band ham radio allocations. It's called the 160 meter band. The wavelengths are so long that it really is kind of not feasible for hams to put up 160-foot towers and stuff like that. So they usually have some kind of relatively short wire, and then they have a large loading coil, which basically is the extra coil, and then they have the ground radials underneath whatever wire goes up in the air or tower or whatever the height they can get, which is about 60 feet maximum. And then so it's similar to the Tesla way of doing it, but it's kind of half and half. So if somebody has a balanced dipole antenna ungrounded, they have a much more difficult time of picking up these signals which originate from the Tesla type transmitter than the guys that have an unbalanced system where part of it is earth and the other part is in the air. So I don't know, there hasn't been enough work done to see what the differences are, because it's kind of a hobbyist thing, and ham radio, it's kind of a Fred Flintstone club. It's not really a good place in this time. But ham radio always had that reputation in the past of, some experimenter figures something out, and whether it's believed or not, it works. So that's how we ended up with electromagnetic radio to begin with, was the experimenter club started by Marconi, and RCA took control of it, and that gave us electromagnetic radio that we know today.
So how did Bruce Gavin get the substation ground system? Was it already there, and did he install it himself? Or what?
He made it himself. He had to build a concrete foundation for just like laboratory building. So he did all the bonded conductors and what have you, embedded in the concrete, in the ground rods and what have you, to get the necessary low impedance. So basically, in the concrete is a mesh of copper cables in a grid. And then that, through the moisture of the concrete and the ground rods, that just very thoroughly bonded to earth. That way, he has terminal comes up out of the floor, then there's no lead inductance because it's all spread out into a grid. And so that way there's no impedances to fight the transmission process. So all substations have grounding systems like that to handle the incredible fault currents and lightning discharges that enter the substation or exit it through the ground. And they usually involve several thousand pounds of copper. They're massive. So you kind of put a small one of those together.
And I would imagine all uninsulated?
Yeah, it's all bare.
So this ham radio approach is a challenge waiting to be put out there.
When I started off with that Crystal Radio initiative, first step is to see how much power can you get from your local AM radio station. And some people actually were running little toy motors and small incandescent lights, but the thing is you have to have that ground, and that is the part that's beyond most people's capability, just to get that necessary grounding. So what I got here is I got 2 tanks filled with water buried in the ground outside the building that the fire department uses to test their fire pumps. When the guy we bought the building from, he built fire trucks. So he got I guess a regular body or whatever from GM, and then he put in all the valving and gauges and pumps and all that kind of stuff. And they used the 15,000 gallon and the 35,000 gallon tanks that were left over from the old Chevrolet dealership. And so those are my ground electrode here. And that gives me a very, very intimate electrical connection with the Earth, so that I have the capability to transmit into the Earth if I can ever get any of that equipment together via the AM radio transmitter. The idea is to put a signal out of here, get an FCC allocation down around 500 kilocycles, and then put a beacon transmitter in, so that there's always a signal coming out of here, probably giving weather data and earthquake data and stuff like that. It's on 24 hours a day, and then it'll be kind of a contest or challenge for people to see how strong of a signal they can get elsewhere. That's one of the primary objectives here. Is a telluric broadcast station. Got the three-phase power on the pole outside, and I got the underground electrode, and I got the AM transmitters, and then the Colorado Springs coils, and that would facilitate that. So I might even try to get a special waiver from the FCC to do a one-day experimental telluric full-power AM broadcast, and do that on a contest level too, see how far it gets out. But these things really are all way, way beyond what can be done with the minimal financing that this operation has. It's next to nothing. So they're good ideas, but I don't see anything happening right now in that regard. Writing equations about it.
Okay, let's see. Yeah, go to 207 area code. Go ahead, say your name and where you're from, and go and ask your question.
Okay, my name's Nicholas Larden, and the 207 area code, that's from me. I'm in North Dakota right now. I guess my question I just have, this is like hypothetical for the future. If for some reason in the future this technology were to be implemented for power transmission on large scales, I guess I was just wondering what that would mean for employment opportunities. I mean, I guess this is kind of like a devil's advocate sort of thing to say, but like in North Dakota there's a lot of line workers, and I guess I was just wondering if there could be some way that they could be reemployed in order to implement lossless wireless power transmission on a large scale.
But doing power transmission on a large scale with this type of thing would be a very unadvisable thing. The problems it would cause would be insane. It's not practical. In Tesla's day, it was one thing when the electrical load was a 50 amp power lamp and that was it. But now, with the energy gluttony of the overpopulation, and to do this on a gigawatt level probably would unleash a massive wave of earthquakes and wipe out computers everywhere, and basically lay waste to any of the research I'm doing, because you wouldn't be able to hear anything out of the Earth anymore. It'd be completely wiped out. And I don't think it would be allowed to happen anyway, because it would interfere. So I don't think anybody has to worry about losing a job over Tesla wireless power transmission. The system, as it stands now, is very effective. The only problem is that there's some malevolent force that's rewiring it from 3-wire to 4-wire to screw everything up. But otherwise, it's a proven system. There's all this talk of electromagnetic, what do they call it, EMF, which is a bunch of crap. EMF stands for electromotive force, but these troublemakers have changed the name around. So now electromagnetic fields. Now we got 2 EMFs. Well, that's already a problem. They don't know what they're talking about. All these power lines are making me sick and whatever. Well, I don't know how many generations of Blackbirds I've seen sit on the 12 kV wires there in Molinas, and the power lines running up and down the street. In my life, in the Pacific Gas and Electric jurisdiction, in the 50 years I lived there, I've never seen any deformity on the birds' feet, any complications at all. The only place I see any deformities in the birds where they have crossed beaks or weird toenails or their feathers stand straight out is the ones that eat the scraps around McDonald's and Jack in the Box. So maybe because when they're putting their mouth and what power line they sit around.
Oh, wow. Yeah, I don't even feel like asking you about 5G. I mean, I can probably look that up somewhere else.
Yeah, I don't think I need to say anything about it.
Yeah.
So when I got started in this stuff, Bell System standards, I would not allow myself to be exposed to more than 200 microwatts. Now the full output of my Bell System TD2 transmitter that I used back then for my research is in your living room 24 hours a day.
Oh, wow.
Yeah.
Yeah, I try to use
about 1 million times stronger than the maximum Bell System standards. So I had Steve McGreevy put together a detector box, no amplification, it was just direct rectification, and then went into the speaker amplifier afterwards, but there was no amplification on the RF, and there was no place in Owens Valley that the Wi-Fi and the rest of the stuff was so strong that it was capable of rectifying in the diode, and no RF amplification was necessary, and there was nowhere to get away from it. That means that's usable electricity that can charge a battery. And I think some people are actually starting to capitalize on that, and they're charging little devices to keep them going without any batteries just by the ambient radio frequency interference. And then the 5G is just going to amp it up even more because the deleterious effects are inversely proportional to the wavelength. As the wavelengths get smaller and smaller, the biological complications get larger and larger. So the whole thing's getting ready to do a big choke.
Do you know anything about, this is just a concept I've heard, that apparently there's I don't know if this would literally mean an even higher frequency or if it's just some sort of colloquial term, but there's supposed to be a wireless frequency that has been referred to by the term 9G or 10G, and ostensibly this frequency is supposed to be harmless. But I'm wondering if you've heard anything about that, or if that's just...
No, I I don't, so I'm not really into that stuff. I suppose once you got up to the infrared range, then it's not really electrical anymore, but nevertheless, the body is a resistor. It's going to turn it into heat, if nothing else. And then, a lot of this, these new medical experiments where people are using red LEDs and stuff like that, which appear to have a very significant effect on the biological organism. Well, I don't see any happy outcome to any of the thing, and it's really sad because we don't need any of this stuff. But these squeaks, they got in there, they destroyed the Bell system, and created this bandwidth flood for their own self-interest. And so now we have a communication system that has absolutely no security. It's got a built-in artificial malevolence, and if it doesn't like you, it cuts off your communications or manipulates it. And don't need any of this stuff. How did we win World War II without silly phones or six-wheel pickup trucks? Can you tell me that?
People were probably able to.
Hey, we're not going to win World War III.
Oh, jeez, yeah. I'm just glad we didn't have World War III, sometime in 2017.
Yeah, well, actually, World War III started the instant World War II ended. So what we're getting ready for now is World War IV. It just seems to be that that's what humans like to do. So, at any rate, that's why we're sending trillions of dollars to China every year. Didn't learn with Japan, did we? Modernistic stuff and lots of money, and then all of a sudden slap them with a bunch of tariffs, and then, now that you funded a nice big navy and all the rest of the stuff, and they get pissed, well, then you got a war again. But people can't learn. So that'll be World War IV will be later. Probably maybe another 4 or 5 years. It'll be good. Yeah. It's like, once you throw up, you feel a lot better. Let it happen. Like, get little stuff out once and for all. Get back to business again. So people have to do something functional in order to live. Like grow food.
Yeah, so it was like less entropy.
But at any rate, we kind of straying off the topic, so I can with this stuff.
Yeah, thank you so much for talking to me. Am I the only person here on this live call, or?
With the other stuff.
Okay, well, thank you very much, Eric.
Okay, you're welcome.
Okay, thanks, Nicholas. Let's see, we're about 250 right now. Does anybody else have any questions? Nicholas, there's not a whole lot of people on the call, but just because of the late notice, I could only send out the notice yesterday, but let's see if anybody does have any questions. Just hit, I think it's 5 star. Let me know if you have a question. The area code is 620. Go ahead and say your name when you're from and go and ask your question. Hi, Eric. My name is Scott from Wheaton, Illinois. This may be can you guys hear me? Yes. This may be a short question. I've been on this long quest to understand turbulence. I wonder if you have any thoughts to throw out there. The nature of turbulence, I should say.
Kind of out of my field.
Okay.
Pretty much just the electrical transmission type stuff. Power, communications, what have you.
All right. Thank you. Let's see, your area code is 319. Go ahead and say your name when you're from and go and ask your question.
Steve from Iowa. Just wondered if you could describe your funding challenge with what you could do with experimentation on this particular project next if you had the dollars.
Well, as I described, I want to get an active caloric transmitting system going. And the primary objective with all of this really is getting the signals out of the inside of the Earth and where people can listen to them, in their own homes. Like the musical seismograph and the Earth stereo and the Earth signals, earthquake precursor signals and all that is just to get that stuff raw on the air for people to listen to. So that's kind of our mandated project here on the government level. Is the telluric reception, the facilities have been provided by the university and what have you for to amplify the seismic mechanical signals and get them out on the air. So that's kind of what I'm after.
Do you have any other questions, Steve, or questions or comments? Or?
No, I don't at this time. I'm still trying to play catch up and get hours to watch your content.
Okay. Let's see. I have time for one more question if there are any. If you have a question, just hit 5 star. So if not, then I guess we can go ahead and wrap it up. If you have a question that we're finishing up here, go ahead and just ask it. Otherwise, please do go to ericpbellard.com. If you're listening to this, if you want to support the nonprofit, ericpbellard.com. There's a donations link in the menu bar. That'll give you information on how to send donations either by mail or by PayPal online. And it is about one C3 nonprofit corporation, so our donations are tax deductible. And as you can see at the conference, given the donations and stuff that came in, definitely going to the projects that were intended to, as you can see with the Colorado Springs replication. And so I guess until the next call, we're going to have conference next year. It'll be the first weekend after 4th of July, and it's possible it might even turn into a 5-day conference instead of 4. And so, go to EnergyScienceConference.com and register for that. If you came to the conference or registered before, most likely you don't have to register again. I just transferred the registrations over to make it easy. Also, if you go to ericpbellard.com, you can go to the blogs, and there's quite a bit of stuff posted in there, with all of Eric's past presentations. There's presentations linked there, but I think you can also
see all the presentations on that page. So I guess until next time, and again, I apologize for the short notice on this call. We're going to get a whole lot of people on, but I wanted to take the opportunity to do this while I'm down here with Eric. And so we'll definitely, we will do more calls like this and get more notice. So, any final words, Eric?
No, I think it's pretty well covered.
Okay. All right, well, thanks everybody for joining the call, and I'll send out the link to YouTube once this is ready for another wrap, and then we'll give announcements on future calls. We'll do an energy tax mailing list from Eric's mailing list. So until next time, we'll see you all later. Thanks, everybody. Thanks, Eric.
Thank you, Eric.
Thank you.
Thank you.
Thank you.
Okay, we're going to go ahead and get started here. Who remembers Dr. Pollock's presentation from last year? Yeah. There was a section in there where there was like a water battery which had no electrolytes in it. All it was water, and it was lighting up an LED. I don't know if you showed pictures of it, but I know that it was discussed. And it's about, the easy water separates. There's a negative and a positive, but there's no electrolyte in it. And you series those up, and you're actually getting electricity out of it. That battery was invented actually by our next presenter. So Kurt has a BA in wireless communication engineering from a national university in Taiwan, and he holds a master's of electrical engineering, an MBA certificate in technology entrepreneurship, and 2 PhDs in electrical engineering and nanotechnology from the University of Washington, where Dr. Pollock is. Kurt's experience includes microwave electronics, nanotechnology, and rapid prototyping. During his PhD, he developed a prototype of Harvest Energy, which I just mentioned, from clean water based on 4th phase water properties. Kurt has been involved in research and technology and development and businesses with startups since 2012. In 2016, Kurt founded a company, 4th Phase Incorporated, along with Dr. Gerald Pollack and Dr. Chris Grunett. Besides the over 1.5 million seed capital that was raised, Kurt was recently awarded with the NSF SBIR for a $250,000 non-dilutive research grant.
So Professor Pollack was my PhD advisor back in the time. We still work together. So he discovered this interfacial water, and 2 very distinctive property of the water is, first, it excludes the small particles away from that little water zone, and we call it exclusion zone water. Part of the reason why, so it's a microscopic image. On the right-hand side is hydrophilic material. In this case, we use a polymer called naphthalene. We're going to talk about it a little more later. And on the left-hand side is basically just water with small particles in micron size in diameter, and people usually call it microsphere. So what happens is, if you have certain material, usually hydrophilic material, by the way, hydrophilic means water love. So when you have something that water would actually be attracted to, that we define hydrophilic. On the contrast, that will be hydrophobic, like the lotus leaf. So when you have hydrophilic material in the water, water will spontaneously repel the contaminants, the impurity, and push it away, further away from the interfacial area. So this is the hydrophilic material I was talking about, and here is just the water, and the little black dots here is the microsphere I mentioned. So this is a still image, but I'm going to show a video later. So that's why we dub it the exclusion zone, because it excludes the impurities, the particles, the contaminants. And the second very noticeable property of interfacial water is the net negative charge. So here on the right-hand side, as I mentioned, is the same material. In this case, we use naphthalene. If you place the electrode in the water, we're going to show more detail later, that you can measure the electrical charge, the electrical potential, up to about minus 200 millivolts. And you move the electrode away from the surface, then the potential drop, the amplitude of the potential drop, and go back to eventually neutral, 0. So here is a quick video. It's just constantly moving by itself. But in this case, it's rotated about 90 degrees. You have the easy generated material polymer on the top, and you have the water with small microsphere, and spontaneously just get pushed away. And this video is 6 times faster than real time. But no matter what, you get a good understanding like why we want to call exclusion zone, because when we see the phenomenon, it's just mind-blowing the first time we saw it. Say that again? So the question is why there's pulsation. It's an excellent question. So these are the phenomena that we observe. And along with the net negative charge we're going to talk about, which leads to the water battery discovery, those 2 evidence lead us to believe that water has a structure at the interfacial region. And because of the structure, it stores net negative charge. So you must wonder so far. So if you can create charge separation in pure water, then where is the energy coming from? What is the original energy source to make water able to separate the charge, and therefore we can potentially tap into that energy source? So it turns out that we find this is another microscopic